students, I'm your Komali Mam. In this session, I'm going to teach you 20 best organic conversions. Actually, organic conversions na students feel difficulty. Why you feel difficulty in organic conversions? Because, for example, let's see question number 1. You see this propene to prop1ol. Okay, propene to prop1. Whenever you see such kind of questions, then immediately fear comes. You're not able to do the conversion. Reason number 1 for that is lack of grip over organic chemistry. If you know each reagent and its function, then only you will be able to do the organic conversions. In this session, I am going to teach you 20 best organic conversions. If you are a beginner too, then you will get a certain idea about its reagent, about the reagent and its function. Whenever you see such type of conversions, you will be able to do easily. Let's begin the session. Are you ready? Watch this video up to the end. Then if you want, you can make a notes of that, and in a description I'll provide you the PDF of this entire 20 conversions and the notes also. Okay. Propene to prop1ol. What is a propene? Prop means 3 carbons. 1, 2, 3. Prop1ene. How we want to convert, students, tell me? Prop1ol. Write that structure also. Prop1ol. This is prop1ol. Now, when you see one particular conversion, this reagent you have to find. Observe the difference between this and this. Here CH double bond CH2 is there. Here CH2OH. I mean, if you observe it, here you are breaking this bond. One H and one OH you are adding. How is that possible? See, one conversion, one route, we can select in different reagents we can select and we can do. What you can do is, which are the commonly using reagents, just identify those reagents and follow. For example, here what I am doing is, for this conversion, CH3, CH double bond CH2, first I will add HBr to this. Okay, HBr I will add in the presence of peroxides. Immediately, when I write this reagent, you should know this function. Then only you will be able to do organic conversion. What is HBr and what is its function? HBr in presence of peroxides shows anti-Markovnikov's rule. What do you mean by anti-Markovnikov rule? The negative part of the species goes and attack to the double bonded carbon having less number of hydrogens is Markovnikov's rule. More number of hydrogens is anti-Markovnikov rule. See, this is, now I am not going to explain what is anti-Markovnikov rule. When you come to organic conversion means already you should have an idea about its the reagent and its function, then only it is possible. Okay, so what is HBr and its in presence of peroxide? Anti-Markovnikov's rule. Anti-Markovnikov's rule. What is anti-Markovnikov's rule? This negative species will attack more number of double bonded carbon having more number of hydrogens. This H plus goes and attack to the double bond carbon having less number of hydrogens. Then we will be getting 1 bromopropane. Okay. So here add aqueous KOH. Do you know what is the function of aqueous KOH, students? Aqueous KOH, this is a nucleophile, goes and substitute in presence of Br, simply to say we will be getting propanol. So in this 1 or 2 minutes of explanation, what you have learned, you have recollected two informations. One is HBr in presence of peroxides do anti-Markovnikov's rule. You are getting a bromine at a first position, and then aqueous KOH function you have learned, it will go and substitute in the presence of the Br, and nucleophilic substitution reaction takes place. Two reagents you have learned and their functions. Okay, so propene 1ol one propene we can convert into propanol by using this. Next, question number 2. Ethanol to 1-butane. Every conversion is different. In every conversion you will get certain knowledge how to do. Once you complete minimum 100 conversions, then you will get super awesome route maps. You can be able to find it out. Okay, now let's see ethanol. What is this ethanol? CH3CH2OH. Convert this ethanol into butane. How can we convert this into butane? What is the difference? First identify the difference. Here OH is there, here C triple bond CH is there. So this OH we should replace and we should get C triple bond CH. Am I right? So how can we replace this OH? Think, alcohols treat with PCl5 or thionyl chloride, any reagent. You no need to use only single reagent. Suppose if you refer one textbook, they may give one reagent, another textbook another reagent. Okay, follow syllabus. Whatever the reagents are there, commonly use those reagents only. Then CH3 thionyl chloride you use, you will get chlorine here. OH plus chlorine. Once you get OH plus chlorine, then treat this with sodium acetylide. Sodium acetylide you treat, then this Na and this Cl goes out and we will be getting our product. So here what I want to tell you, two reagents and its functions you have learnt. What is that? SOCl2 thionyl chloride, one of the OH is replaced by the chlorine, and here sodium acetylide you have used and this group you have introduced in place of chlorine. Question number 3. Question number 3. 1 bromopropane to 2 bromopropane. What is that, students? Tell me. 1 bromopropane to 2 bromopropane. Identify the difference. First, just identify what is the difference between these two. 1 bromo. Here bromine is at first position. Here bromine is at second position. How can we change that? How can we do that conversion? Let's see. CH3CH2CH2Br. Now add alcoholic KOH, new reagent. See, new reagent. Before we have used aqueous KOH. Now I am using alcoholic KOH. What this alcoholic KOH will do? Dehydrohallucination it will do. What do you mean by dehydrohallucination? Here this OH group and here this H both goes out as an H2O, HBr. Simply to say alcoholic KOH, different mechanism, but simply remove this nucleophile is a strong base, abstracts the proton, H plus comes out, again after that Br minus goes out, but simply to say one H and one Br you remove, you will be getting prop1ene. And then now tell me, you have propene, you want to get 2 bromopropane. What is the reaction you have to do? Immediately the reagent should come in your mind, that is HBr. When it is possible, when you previously studied organic chemistry in a proper manner, then only you will get this idea. Okay, suppose if you are the beginner, just identify the reagent and its function. Whatever I am teaching, just write that okay, this is the function and this is the reagent, this is the function. Here I will use HBr. HBr in presence of peroxides is anti-Markovnikov's rule. Only HBr is Markovnikov's rule. Markovnikov's rule. What it will do? The negative part of the species goes and attack to the carbon having less number of hydrogens, and the positive part of the species goes and attack to the carbon having more number of hydrogens. So CH3, CH double bond breaks, Br minus comes here, H plus comes here. So we will be getting 2 bromopropane. Clear? Next question. Tolin to benzyl alcohol. What is the formula of tolin? Structure of tolin. This is tolin. We have to convert into benzyl alcohol. Benzyl alcohol. Identify the difference. What is the difference here? Here one H we should replace, and in that place we have to put OH. There is no difference between remaining any structure, only difference is H place we are going to substitute OH. That is only the difference, right? Now what you do is take CH3, okay, then do the UV or any heat chlorination you do, chlorination. When you do chlorination, then allylic substitution takes place. Here one Cl goes out, we will be getting chlorine here, and then halogen substitution, I mean halogen replacement. How we can do? Just now we have learned before question, aqueous KOH. If you use these two play very easy. See, aqueous KOH and alcoholic KOH. Alcoholic KOH remove HBr, one hydrogen, one halogen you remove. Aqueous KOH, OH will go and replace, okay, the halogen. So remove this OH here. We will be getting the product here. Benzyl alcohol is our product. Okay, students, clear? See the functions. See, identify the functions. Once you're doing like this conversions, you get very good grip. Next, benzene. Take a benzene, and this benzene we should convert into 4-bromo-nitrobenzene. What is that? What do we have to do? 4-bromo-nitrobenzene. Here, what I want to do is, two groups I want to substitute. How can I substitute two groups is, first, let me take bromine and I will benzene, and let me do halogenation. If I do halogenation, bromination in the presence of iron as a catalyst, what will be our product? Bromobenzene is our product. Okay, and then I will treat with concentrated HNO3 plus concentrated H2SO4. Then what will happen? Nitration mixture it is. What is this, students? Tell me. Nitration mixture. If you do this nitration, then this is ortho-para directing group Br. Br is an ortho-para directing group. So NO2 comes here. Then para position major product and ortho is a minor product. So here is our major product. And why, ma'am, this is ortho-para direct? Another class. Which is major, which is minor in ortho-para orientations, we will study. It is a separate session. If you want me to do, just put in a comment section what topic you want me to do. The best video, I will make a video for you all. Next, benzyl alcohol 2-phenyl ethanoic acid. What is this benzyl alcohol formula? This is benzyl alcohol. You want 2-phenyl ethanoic acid. 2-phenyl ethanoic acid is the formula. Identify the difference. Here OH you should replace with a COH. How is that possible? How is it possible? See the route map. We have to take CH2OH benzyl alcohol, treat with thionyl chloride or PCl5, anything. Just replace this OH with Cl. Once you replace with OH with Cl, treat with KCN. Ma'am, how I should get that idea? How I should get that idea? You will get automatically when you practice certain conversions, okay? If you complete the organic chemistry reactions, preparations and properties, if you complete, then if you certain conversions, if you practice, automatically new ideas will come. But if you are first starting, you are the beginner, then you don't get the idea directly. You should check it out, all the reagents and its functions. Okay, PCl5 is replacing this OH from here, and then treat with KCN. If you treat with KCN, K and Cl goes out, we will be getting here CH2, here Cn will come. Then you treat this Cn came na, you do hydrolysis in presence of acidic medium, then that Cn converts into CH2COOH. In such a way, 1, 2, second position phenyl is there, 2-phenyl ethanoic acid because 2 carbons are there. Next question, ethanol to propane nitrile, propane nitrile. Ethanol, write the formula of ethanol. Ethanol, propane nitrile structure is structure propane nitrile. This is propane nitrile, or simply I will write Cn. Okay, na? Now CH3 CH2OH. Now I will treat with this OH we want to replace. See, already we have done. How can you replace that OH with a Cl? Got the clarity? PCl5 or SOCl2. Use PCl5. Then CH3, CH2, Cl. Okay, done. After that, once you have done this, then treat with KCN. If KCN, KCl goes out, CH3, CH2, Cn. If you want propanoic acid, next step also you know. What you can do? Hydrolysis you do. In presence of acidic media, hydrolysis you do, then Cn group will be converted into COH. So in such a way you can do the conversion. Next, aniline to chlorobenzene. See how excellent conversions are. Aniline to chlorobenzene. Aniline to chlorobenzene. How can we do aniline to chlorobenzene? This group we want to replace. Aniline NH2 group is not a good living group. We can't replace that much easily. So what we can do? We can do diazotization. What is this diazotization? Students, tell me what is the reagent? Take aniline, treat with NaNO2 plus HCl. Okay, this will give us, HNO2. This nitrous acid will do diazotization. Diazotization. In cold bath we do this reaction. 0 to 5 degrees Celsius we will maintain. Then what will happen? This NH2 group will be converted into N2 plus and Cl minus. This is a very good leaving group. Benzene diazonium chloride. What is its name? Benzene diazonium chloride, which is a very good leaving group. Then what we have to do? Use CuCl. This is which reaction? One of the famous reaction, Sand-Meyer reaction. Which reaction? Tell me. Sand-Meyer reaction. What this Sand-Meyer reaction will do? It replaces this. Chlorine goes and substitute here. This is chlorobenzene. So you have learnt here diazotization process. Here you have learnt about the Sand-Meyer. What is the product? How to write a product you have learnt. Correct? Next, 2-chlorobutane to 2,3 dimethylhexane. First write the structure. 4 carbons, right? 4 carbons, 2-chlorobutane. This is 2-chlorobutane. Next, how we should convert? We have to convert into 3,4 na? Okay. 3,4 oh here 3,4 dimethyl cyclohexane. Just observe it, what kind of reaction it is. Guess, any guess what is this reaction? One of the most famous reaction, that is called Orge reaction, because here the number of carbons are 1, 2, 3, 4. Here 1, 2, 3, 4, 8 carbons, exactly double the number of carbons. For even number of carbons, what is the best test we will do? What is the best one? Orge reaction is one of the best reaction for to get the even number of carbons. Okay, tell me the product, students, tell me product, how to write. What is the reaction? I will write this Cl this side and CH3 down so that it is easy to write. What is the reagent? Sodium metal we will take, and in the presence of what reaction takes place? Dry ether. Dry ether. Dry ether. Then what will happen? Tell me. Dry ether, this Na and Cl, 1 Na, 1 Cl, 1 Na, 1 Cl goes out. Connect the bond between these two and write. So, CH3, CH2, CH, CH3, CH, CH3, CH2. See, exactly I am writing everything. Okay, I am not, this directly I am connecting to this, no change. 1 Na, 1 Cl goes out. 1 Na, 1 Cl goes out. So what is its name now? 1, 2, 3, 4, 5, 6. 3,4 dimethyl hexane is its name. Correct? Whatever we got, we got. What is this reaction? Urge reaction. So in this conversion, what you have learned? Urge reaction. So this video will help you to learn different types of reagents in a short time and its functions. Next question, 2-methyl 1-propene 2-chloro 2-methyl propane. What is its name? 2-methyl prop-1-ene. So I will write first prop-1-ene, then second position methyl group. So how I should convert this? I want to convert this into 2-chloro 2-methyl propane. Identify the difference. Here I am breaking this bond and just I am adding one hydrogen here, one chlorine here. So how is it possible? The negative part of the species coming and attacking to the double bonded carbon which is having less number of hydrogens. That is a which rule? That is called as an Markovnikov's rule. Two things are Markovnikov's rule, anti-Markovnikov's rule. Alcoholic kavach, aqueous kavach. Urge reactions, fatigue reactions, urge fatigue reactions. Like this, if you learn in such a way, you know, you will do the conversions fatafat you will do. See here HCl I am adding. HCl, you know, if you add, the negative part of the species goes and attack to the double bonded carbon having less hydrogens. The positive part of the species goes and attack to the double bonded carbon more hydrogens. So we will be getting our product. That's it. Next question, ethyl chloride to propanoic acid. How to get ethyl chloride? This conversion you only should say. Ethyl chloride to propanoic acid. If it is an ethanol, we learned. Ethanol is given means how to get chlorine here I told you. Just treat with PCl5 or thionyl chloride. Already ethyl chloride only given. Then what you do directly? You should get here Cn you should get here. So K and Cn goes out, K and Cl goes out as KCl. You will get CH3, CH2, Cn, propane nitrile. They may ask you to stop here also according to the question. Or they are asking propanoic acid. Do hydrolysis. If you do hydrolysis, what you get, students tell me? CH3, CH2, COOH. This Cn group can be converted into COH group. So you get propanoic acid. Next question. But1-ene to But1-ene. But1-ene to N-butyl iodide. N-butyl iodide. Ma'am, how can I get this butyl iodide? See, only difference here and here is, what is the difference? You are breaking this bond, you are putting one H here, one iodine here. First, you have to see what is the difference between both. Okay, one HI is the difference. If HI is the difference, what you have to do? Directly add HI, but HI you want anti-Markovnikov's rule. What do you mean by anti-Markovnikov's rule? The negative part comes and attack carbon having more hydrogens in the double bond. Okay, so this I is coming here, but no, HI don't do anti-Markovnikov's rule. Only HBr, this is an important, tip you should put in your mind. Only HBr in presence of peroxide only shows anti-Markovnikov's rule. No other thing shows the anti-Markovnikov's rule. Okay, so this HI direct addition not possible. Then what we should do? Take butene, which butene? 1-butene, and now treat with HBr, because only HBr can do in the presence of peroxides. Once you treat with HBr in the presence of peroxides, we'll be getting CH3, CH2. Tell me, what do you mean? What is the product where Br comes first place? Peroxide means. No peroxide, Br comes at second position. Okay, then you treat this with one of the famous reaction, Finkelstein reaction. What is this reaction? Any idea? Finkelstein reaction. What do you mean by Finkelstein reaction? Say how many reagents you are covering here? This Na, chlorine or bromine substituted halides, what we can do? We will treat with NaI. This is a solvent. NaI, iodine will go and replace. Iodine will go and replace. This is one of the famous reaction. What is the reaction, students? Tell me. Finkelstein reaction. Finkelstein reaction. Finkelstein reaction. What do you mean by Finkelstein reaction? Iodine goes and replaces the other halogen. This is one of the halogen substitution reaction. Okay. Next. 2-chloropropane to 1-propanol. 2-chloropropane. What do you mean by 2-chloropropane? This is 2-chloropropane. From here, what you want to get? You want to get propane 1-ol. Propane 1-ol you want to get. 2-chloropropane to propane 1-ol. So how is it possible? How is it possible? We have to identify the difference. Between these two, what is the difference? You want to replace this chlorine and you should put that OH at the first position. Then how can you do that? Use alcoholic KOH. When you want to remove that group and position change means directly you can use alcoholic KOH. Position change you want in next step. See here, I will use alcoholic KOH means KOH in ethanol. Then what will happen? One Cl, one H goes out. You will be getting propene. Then propane, how can you convert into propanol? This step already we have done. What to do? HBr in presence of peroxides. Again, how many times you are getting this reagent? See students, how many times you are getting this reagent? How important role it is playing. Then this Br you want to replace. How can you replace this Br? This step also you have learnt aqueous KOH. What this will do? This OH goes and replace. So, aqueous KOH, alcoholic KOH function, anti-Markovnikov rule, and named reactions you should have very good grip. Okay. Next. Isopropyl alcohol to iodoform. See, this is one of the named reaction. Which named reaction? Iodoform reaction. Let's see. What is this isopropyl alcohol? First, I will draw the structure of isopropyl alcohol. Okay. Either I can draw like this or I can draw its structure like this. This is isopropyl alcohol. I want to convert this into iodoform. Iodoform. Okay. This first what I do is I will take isopropyl alcohol and I will treat with CrO3 chromium anhydride. Then I will be getting acetone. The compounds which are having CH3 C double bond OCH3 or CH3 CHOH. These compounds gives a positive iodoform test. What is the iodoform reagent? Iodine over NaOH. Once you use this, then CHI3 is our product. What is the haloform general formula? Here are mechanisms I am not discussing. CHX3. Okay, what is the iodoform formula? CHI3 is a formula. Okay, next. This is what haloform reaction it is following. Chlorobenzene to paranitrophenol. Next conversion. See the next conversion. Chlorobenzene. This is paranitrophenol. How beautiful reactions are. How beautiful reactions. How many conversions you are learning in one video. Many reagents and their functions. Directly observe the difference here and here. Here chlorine is there, here OH is there, here NO2 is there. Two groups you want to replace. How is that possible? How can you replace two groups? First, chlorine. This is an haloarene. Haloarenes don't undergo direct nucleophilic substitution reactions. One of the most famous named reaction called Dawes process. In Dawes process, what we will do you remember Dawes process? Here we will use NaOH over certain conditions like 600 Kelvin temperature, 300 atmosphere pressure, then H and Cl goes out, we will be getting sodium phenoxide. This sodium phenoxide further hydrolysis, then we will be getting H and OH here happens and we will get our phenol. Once we get the phenol, do nitration. What is the nitration mixture? Concentrated HNO3 plus concentrated H2SO4 if you add, then we will be getting this OH is ortho-para directing group where para position is a major. Okay, this is a why major minor. Another session, ortho and para directing case I will discuss. So what is the product here, students, tell me? Para product is a major product. Is it clear? Is it clear? Next, 2 bromopropane to 1 bromopropane. This is, you can try this question now. Can you try this question? 2 bromopropane to 1 bromopropane. What I told you, you want to directly, no changes, just a second position to first position you want to replace. That's it, move. How is it possible? Alcoholic AOH use, remove H and Br. Next step is, first position you want Br means what is the rule you should follow? Anti-Markovnikov's rule. Then which is the reagent? HBr in the presence of peroxides. Very good. Come on. Tell me, students, tell me. CH3, CH, Br, CH3. What you should use now? Alcoholic KOH you use, then Br and this H both goes out, you will be getting propene. Then what you should use? HBr you add in the presence of peroxides. What is the rule it is following? Anti-Markovnikov's rule. Then this Br minus comes and attack double bonded carbon having more hydrogens. This bond breaks. This H plus goes and attack the double bonded carbon having less hydrogens. Then you will be getting a Br here. Okay. See the next question. Chloroethane to butane. Can you try? How is it possible? Chloroethane to butane. Test yourself. Test yourself. Chloroethane to butane. I'll cover in this video itself this question and 3 questions. Just simply try if you can. I will discuss here only. Just take a screenshot and try. Okay. I will only discuss because all are different conversions, right? You might get an idea or not. So I will discuss. See, this one you can try. Chloroethane to butane. Chloroethane. Ethane to butane. Butane is how many carbons? Total 4 carbons. So how can you convert 2 carbon alkyl halide to 4 carbon alkyl halide, 4 carbon alkane? What is a famous reaction? Urge reaction. What is a Urge reaction, students, tell me? CH3, CH2, Cl. You add sodium metal in the presence of dry ether. In the presence of dry ether. So what will happen? 1 Na, 1 Cl. 1 Na, 1 Cl goes out. We will be getting butane. Butane is our product. What is the name of the reaction? Famous reaction? Urge reaction. This is for even number of carbons. Even number of carbons preparation, we will be using this. Next, benzene to diphenyl. Benzene to diphenyl. What do you mean by benzene? This is a benzene and we want to get a diphenyl like this. How is that possible? Fittig reaction. Which reaction? Fittig reaction. What is this Fittig reaction? See, take before Urge reaction, what you have taken? Alkyl halide you have taken. Here, aryl halides we have to take. Here R if you take, benzene plus R you take, that is Urge reaction. Benzene R plus benzene if you take, that is a Fittig reaction. Then treat with the sodium metal. Then we will be getting 1 Na and 1 Br. 1 Na and Br goes out, we'll get this. But in the question, they're not asking from bromobenzene, they're asking from benzene. So how can we get bromobenzene from benzene? Tell me how to get this benzene halogenation. Halogenation. What is a halogenation? Bromination reaction? Add bromine in the presence of iron as a catalyst. Okay, conversion is clear, students. Next, tertiary butyl bromide to isobutyl bromide. Tertiary butyl bromide. Tertiary butyl bromide. This is tertiary butyl bromide. Then I want to get isobutyl bromide. Isobutyl bromide. So you should have an idea about the structures. Then only you can be able to do the conversions. Are you getting my point? Then what you should do? CH3, C, CH3, CH3, Br. First do, here position is changing, if position changes, what reagent we have to use? Alcoholic KOH, you use, change the one Br, one H goes out, what you get students, tell me? CH3, here double bond CH2, and then you want Br at first position. So what is the reagent? HBr in presence of peroxides. Then anti-Markovnikov's rule, double bond breaks, H plus comes to the carbon having less hydrogens, Br comes to the carbon having more number of hydrogens, and this is our product. Clear? Isobutyl bromide is the product. Last question. Aniline to phenyl isocyanide. How to get aniline? How to convert aniline to phenyl isocyanide? First write the structure of aniline, and we want to convert into phenyl isocyanide. It is one of the most famous named reaction. That reaction starts with a C, first letter C. Named reaction starts with first letter C. Try this. Simply. I did not discuss in this video what is the name of the reaction. It starts with a C. Put in comment section what is the name of the reaction and let me know how was this video. And in this video I have covered different reagents, right? I hope this video helpful for you a lot. If you want from me more videos like this, mention which topics you want so that I'll make best videos for you all. My name is Komali. I am your chemistry mentor. Thank you so much for watching this video. See you again in next video. Have a nice day.